Hello friends, welcome to our channel, Gajpal A-Learning. In this video we are going to study about assay of potassium chloride carried out by precipitation titration. So let's start the video. Assay of potassium chloride carried out by precipitation titration. Precipitation titration is a chemical analysis technique used to determine the concentration of an ion in a solution by causing it to react with another ion to form a precipitate. In your case, you want to determine the concentration of potassium ions, K+, in a solution using precipitation titration with silver nitrate, AgNO3, as the titrant. Here's a detailed procedure. Materials and reagents used. Potassium chloride, KCl, solution of unknown concentration. Silver nitrate, AgNO3, solution of known concentration, titrant. Potassium chromate, K2CrO4, indicator solution. Distilled water. Burette, Erlenmeyer flask, stirring rod, white porcelain crucible, Bunsen burner or hot plate, glass funnel, filter paper, analytical balance. Procedure. First, preparation of potassium chloride solution. Start by preparing a known volume of the potassium chloride solution. Record the volume and any relevant information. Second, preparation of silver nitrate solution. Prepare a standard solution of silver nitrate by dissolving a known mass of AgNO3 in distilled water to make a solution of known concentration. Ensure that the silver nitrate solution is accurately standardized. Third, indicator solution. Prepare a potassium chromate indicator solution by dissolving a small amount of potassium chromate, K2CrO4, in distilled water. This will be used to signal the endpoint of the titration. Fourth, precipitation reaction. In a clean Erlenmeyer flask, add a known volume of the potassium chloride solution. Add a few drops of the potassium chromate indicator solution. The solution should turn yellow. Fifth, titration. Start the titration by carefully adding the silver nitrate solution from the burette into the Erlenmeyer flask containing the potassium chloride solution. AgNO3 reacts with KCl to form a white precipitate of silver chloride, AgCl. AgNO3 plus KCl right pointing arrow AgCl, precipitate plus KNO3. Sixth, endpoint detection. Continue adding silver nitrate solution slowly while stirring the solution constantly. The yellow color of the potassium chromate indicator will change to a reddish-brown color when all potassium ions have reacted to form silver chloride precipitate. This color change indicates the endpoint of the titration. Seventh, record the volume. Record the volume of silver nitrate solution required to reach the endpoint. This volume is used to calculate the concentration of potassium ions in the original KCl solution. Calculations. Use the volume and concentration of the silver nitrate solution and the stoichiometry of the reaction to calculate the concentration of potassium ions in the KCl solution. The formula for calculating concentration is C1V1 equals C2V2, where C1 equals concentration of silver nitrate, known. V1 equals volume of silver nitrate solution used, recorded during titration. C2 equals concentration of potassium chloride, unknown. V2 equals volume of potassium chloride solution, known. Solve for C2 to determine the concentration of potassium chloride. Remember to perform this titration carefully, ensuring accurate measurements and observations. Proper laboratory safety precautions should also be followed, including wearing appropriate protective gear and working in a well-ventilated area. Thanks for watching this video. If this was helpful, then please kindly do a subscribe to our channel. Thank you.